Engineer Hew Robert, Malaysian, multilinguist and palm oil processing specialist, was born April 1953. Obtained his BSc Mechanical Engineering second class upper degree at the University of Birmingham, England, 1974 to 1977. Has an MBA from the University of Brunei and Henley Management College, United Kingdom, 1988 to 1992. He is a registered engineer, Malaysia, Chartered Engineer, UK, Fellow Institute of Engineers, Malaysia, Member Institute of Mechanical Engineers, UK, Council Member Institute of Engineers, Malaysia. Engineer Hew has many years industry experience in diverse sectors of global economy, including the palm oil industry, general industry, as well as oil and gas industry. He was at Felder Mill Corporation, process engineer, Lamsoon Oil and Soap Manufacturing project manager, Wembley Industries, Industrial Plant Division general manager. Engineer Hew has been involved in design and construction of many plants, including Tetra Pak and Alpha Laval soft drink process plant, Alpha Laval palm oil physical refining plant, palm oil drums refilling plant, palm oil packing plant, others involving contracting, planning, costing, design, and implementation of turnkey projects, and they include Brooklyn Palm Oil Mill Boiler Plant for Dunlop Estate PLC, 30-ton per hour palm oil mill for Harrison's and Malaysian Plantation PLC, 30-ton per hour United Malaysian Palm Oil Mill, Johor, Malaysia, 30-ton per hour Batu Palm Oil Mill for Austral Enterprises PLC, 40-ton per hour Sabuntai Palm Oil Mill Limited, Indonesia. There are yet many more. The 100-ton per day Coa Palma Palm Oil Physical Refinery, Honduras. And this involves design, fabricate, install, and guarantee. He was also Executive Director, Colossal Industries PLC, offering services in designing, fabrication, and commissioning of complete palm oil mill projects, as well as modification and upgrading of existing ones. The list goes on and cannot be exhausted here. Ladies and gentlemen, this man is the colossus of palm oil processing and engineering, and we are indeed privileged to have him speak to us today. Please welcome Engineer Hew Robert.
Hi everybody, welcome to my presentation on how Malaysia can be successful in the oil palm business. I have often been asked by my overseas guests as why oil palm and rubber, being native trees from West Africa and Brazil respectively, are being so successful to be planted in Malaysia. Today, I will talk on oil palm. I will touch on oil palm history in Malaysia, oil palm extraction process, Felder development story, and a summary of how Malaysia can be successful in the oil palm business. Now my first topic is on the palm oil history of Malaysia. The oil palm is originated from West Africa. In year 1848, it was introduced to Indonesia. In 1870s, the palm was introduced to Malaysia. Experimental planting was started in 1910s. In 1960s, Malaysian government included palm oil business and another source of national income. From 149,900 hectares planted in 1970, Malaysia managed to increase total planted area to 5.85 million hectares in 2018. From 1961 to year 2018, there's an exponential growth of oil palm being planted in our planet. Do take note that Malaysia is number one until year 2008. They're being taken over by Indonesia thereafter. This map shows the location of Malaysia. Singapore is here and Indonesia is here. Malaysia has land mass of 330,000 kilometers square and with a population of 33 million people. Indonesia has 5.8 times more land and 8.4 times more people than Malaysia. Many Malaysian companies invested in oil palm plantation in Indonesia due to shortage of land and labor since 1980s. Now, oil palm business, without its risk. Being a commodity, its price per ton does fluctuate according to supply and demand. Currently, palm oil is having its best price at $1,700 ringgit per ton due to Ukraine war. In year 2019, Indonesia is number 1, Malaysia is number 2, and Nigeria number 5. Why oil palm is so highly in demand in world vegetable oil market? This graph has the answer. In terms of oil yield per hectare of land, oil palm is the most productive crop in our planet. Oil palm can yield 2.84 tons of oil per hectare per year, as compared to the next most productive oil, sunflower seed oil. It can only produce 0.71 tons per hectare per year. How about environmental destruction brought up by Greenpeace movement and other competitors? The fact is there is no other means to replace oil palm for food supply as shown in this graph. Assume that only one oil crop is needed to feed world population in 2018. Only 77 million hectares of oil palm is required to feed the whole world population in 2018, as compared to its nearest rival, soybean oil. It will require 487 million hectares to do the same job in feeding the world population. Having briefly introduced background on oil palm, I now present how palm oil and palm kernel are extracted from oil palm fresh fruit bunches, that is FFB. From first mill in 1920, Malaysia is now having 457 mills of various capacity. Mills from 1920 to 1970s were built with technology from Holland. In 1970 onwards, Malaysia started fabricating machinery and equipment for our own palm oil industry. Malaysian engineers are now in a position to offer the technical services and expertise to customers in Indonesia, Latin America, and West African countries. I now go into general details of palm oil process. This is the material flow chart. The FFB, once harvested from oil palm plantation, are going through various treatment by process involving heating, sterilizing, screening, stirring, pressing, pneumatic separation, nut cracking, and clarification. Final products are crude palm oil, palm kernel, and palm shell. Palm shells, being a byproduct, are mainly used for solid fuel for cement kiln drying and carbon black market. Fresh fruit bunches harvested from plantation are transported by trucks or tractors to nearby mills. The fruits are stored in this loading ramp. The fruits are then transported by scraper arm conveyor to sterilizer station. Fruits must be processed within 40 hours. If not, the oil will turn acidic or sour. FFB are fed by conveyor to the sterilizers. These are the sterilizing station. These are called vertical sterilizer. This sterilizer is to inhibit enzyme in FFB so as oil in FFB will not become acidic or turn sour. It also softens and loosens fruits from the bunches. Sterilizer FFBs are conveyed to thresher to separate into fruits and empty bunch. Empty bunches are solid waste that can be used for mulching for plantation or further processed to be used as solid fuel for steam boilers. These sterilizer fruit bunches are thrashed in this rotating drum. This drum will separate fruits from the empty bunch. The fruits will go through the slot here. Empty bunch will be kept inside this drum while rotating. The next stage of the process is to extract oil from the palm fruits. The fruits are conveyed to a digester to peel off the mesocarp from the nut. These are the peeling arms that take the pulp out from the fruits. The digester mass is then fed into a screw conveyor, screw press. By rotating the two screws, oil is squeezed out from the digested mass. We now have the press liquor from the screw press and the press cake. We will then have to separate the press liquor into crude palm oil, slush water, and organic solid matter. We use clarification process via mean machinery such as clarifier tank, descender, soilage separator, and vacuum dryer to extract crude palm oil from the press liquor. Now for the solid portion, the press cake, from the screw press, we use the bed cupping and kernel recovery process to extract palm kernel from the press cake. This is a typical bed cupping station. Its function is to get rid of the de-oil pericarp from the palm nut. Press cake is being broken down into fiber and nut in this cake breaker conveyor. They will then be separated pneumatically through a wind tunnel here. The nut will be further polished. The nut being heavy will come down and further polished so as to get rid of fiber that are still stick to the nut surface. The press fiber, being lighter, will be carried by the pneumatic air into the fiber cyclone and to be burned in a boiler as a solid fuel. This conveyor is designed with lifter so as to pick up the press cake into press fiber and nut. We now have to extract palm kernel from the palm nut and to send the palm shell to steam boiler as solid fuel, or to sell the excess palm shell, if any, as solid fuel for other industries or as carbon black raw materials. This is a typical kernel recovery station. It mainly comprises of nut cracking machine, silo, conveyors, pneumatic separation column, ducting, and cyclones, and hydrocyclone. These are the pictures of the major machineries in this station. This nut cracker is to crack the nut into shell and kernel, the pneumatic cyclone to separate the fiber from the nut, and the hydrocyclone to separate small kernel and big shell. Palm oil mill will require water, steam, electricity, and compressed air to operate the process machineries. As palm oil mills are normally located at center of plantation, raw water will be sourced from nearby river source or underground source. The water will then be treated as potable or boiler water. Palm oil mill need steam for both power, that's electricity generation, and process heating. Mills in Malaysia are now equipped with electrostatic precipitator to meet more stringent pollution control regulation. Electricity is generated by means of steam-driven generator or diesel generator in palm oil mill. Now I need to stress the importance of fuel steam power balance concept. The concept of fuel steam power balance are to be considered when planning a plantation from day one. Palm oil mills generate solid waste such as empty bunch, pressed fiber, and shell. These solid wastes are burned in a special designed steam boiler, not only serve as an incinerator to dispose of the solid waste and also to generate electricity via steam turbine. Exhaust steam from steam turbine will be used for process heating. Mills that run on solid waste for power generation will have much lower production cost and hence more competitive to other mills in the long run. A mill of 12 tons per hour capacity will have sufficient fuel from the solid waste without having to rely on diesel fire generator, thus meeting the fuel steam power concept of mills cost optimization. Felda is credited in Malaysia to have changed the social and economic condition of the rural poverty-stricken community. Felda had resettled many rural poor into newly developed areas called Felda scheme. Each scheme has 100 families. Each family was given 4.1 hectare or 10 acres of 2-year-old young plants. Each family is to maintain and harvest fruits from their own land. The fruits will be sold to Felda palm oil mills. Each Felda mill is to serve 3 schemes produced. Felda managed to lift poverty out from thousands of rural poor families. They are able to access to modern amenities, be self-reliant and self-managed. There are now 317 such schemes in Malaysia. Felda's integrated approach for palm oil development for landless people is a great model for many countries to emulate. Now, why Malaysia is successful in oil palm business? Oil palm itself is the most productive crop in our planet. Demand for vegetable oil is in tandem with growth of world population and affluent lifestyle, especially in China and India. Initiative carried out by Malaysian government to include oil palm as another business source of income, spearheading both public and private investment on this business. In year 2018, 72% of the plantation are owned by private sector. The rest are smallholders and Felda scheme settlers. In total, there are 5.85 million hectares being planted in year 2018. Now, palm oil industry need to add value. Besides palm oil mills, there are kernel crushers to turn palm kernel into palm kernel oil. There are 42 such factories. And then there are 50 refineries in Malaysia to turn the crude palm oil into refined bleached deodorized palm oil, palm oilin, palm sterling, and also refined bleached deodorized palm kernel oil, palm kernel oilin, and palm kernel sterling. We also have 20 factories making oleochemicals. Oleochemicals are derivative of palm oil. For example, cocoa butter equivalent and cocoa butter substitutes. Cocoa butter equivalent can be used to make equivalent chocolate oil just by mixing color and sugar. We also have 19 factories making biodiesel. Palm oil can be used as biodiesel to be burned in combustion engine for cars, trucks, and even aeroplanes. In the event world palm oil price has come down to so low, Malaysian government will encourage the use of biodiesel so as to burn off all the palm oil instead of selling at a loss to the world market. With this final slide, I said big thank you to you all, and hope all you do well in the future. Thank you.